Hi, hello. This is Sadish Kumariam, Assistant Professor, Department of Agriculture Engineering, Kongnadu College of Engineering and Technology. Today, we are going to discuss about size reduction practices followed in food industry or food processing industry. Okay. In this presentation, what are all the points going to be covered? First one, introduction and principles of size reductions. Second one, forces used in size reductions. Third one, energy requirements in size reductions. And fourth one, size reduction equipments. And then fifth one, criteria for selection of combination process or size reduction process. And then sixth one, the applications of size reductions in food industries or processing industries. Okay. First we are going to see about the basic introduction about size reduction. Size reduction is the process of reducing large solid unit masses into small unit masses or coarse particles or fine particles. Size reduction is a process of reducing large particles into small particles, small unit masses or coarse particles. Okay. Size reduction process is also termed as combination process, diamondization process, and then pulverization process. Okay, size reduction otherwise called as combination, diamondization, and then pulverization. Okay, solid pieces of food is reduced by the application of grinding, compression, or impact process. Okay, in many food processes, it is frequently necessary to reduce the size of solid materials for different purposes. In many food process industries, it is frequently necessary to reduce the size of solid materials is different for different purposes. Okay, benefits of food processing due to size reduction: increase the surface area to volume ratio of the food, increasing the rate of drying, increasing the rate of heating or cooling process, improves the efficiency and rate of extraction, facilitating the mixing and blending processes, and then facilitates heat exchange, chemical and biological reactions. Okay, these are all the benefits of size reductions in food industry, in food processing industries. Okay. Next, we are going to see about the classification of size reductions. First classification is chopping, cutting, slicing, and dicing. In the case of chopping, cutting, slicing, and dicing, first point is larger to medium, and the food materials converted into large size into medium sizes. For example, stewing steaks, cheese, and then sliced fruit for cannings. Okay, these are the example for large to medium converting of food products. Okay, next, medium to small converting. Medium food size particles are converted into the small size of food products. For example, sliced green beans and then diced carrots. Okay, next we move to third classification of chopping, cutting, and slicing and dicing. Minced or shredded meats, flaked fish or nuts, unshredded vegetables, small to granular types, granule conversion of food materials. Okay. Next, we have moved into the second type of size reductions, milling to powders or paste of increasing fineness of particular products. For example, grated products, spices, flours, fruit nectars, powders, sugar starches, and then smooth paste is the example for milling to powders. Okay. Next one, emulsification and then homogenization. Homogenization means the different size particles are mixed into or distributed into same size of particles. The different size of particles are distributed into homogeneous size of particles. For example, milk homogeneous essential oils, butter, ice, and cream and margarine. Okay, these are all for example for homogenization process. Okay. Next one, we are going to discuss about forces used in size reduction process. Okay, and the types of forces commonly used in food process are compressive forces, impact forces, addition forces or shear, and then cutting forces. These are all the basic forces apply into the food processing industry, particularly size reduction process. Okay, In a combination operation, more than one type of force is usually acting. Then size reduction produces more than one type of force will be acting in the size reduction process. Okay. For example, crushing, grinding, and milling take place in powdered sugar, flour, mustard, and cocoa production. In the case of powdered flours, uh, powder flour production, crushing, grinding, and milling forces will be acted on the flour making process. Okay, flour means, for example, flour means grind flours, atta flours. Okay, this is the example for flour making. Okay, first picture shows compressive force. Compressive force. Second picture shows impact force. Third picture shows rotation force. Fourth sixth picture shows cut force. Okay, okay. In the compressive force, nutcracker, cracker, or crushing soles will be example for compressive force. Hammer mill is example for impact force, and then disc addition mill is example for addition force. Scissor or knife is example for cutting force. Okay. The principles and mechanisms of combinations of food or size reduction of foods. Okay. First one, compressive. Compressive forces are used for force or crushing up or materials. Impact forces can be regarded as general purpose forces. Okay. Next, shear or addition forces are applied in fine pulverization when the size of product can reach the micrometer range. Okay. Ultra fine grinding is associated with process in which the submicron ranges of food particles is attained. Cutting is given different particle size and maybe even produce a definite shape. Okay. In the case of compressive forces, it only using for breaking of hard materials. Impact forces is general forces using for break down the particular materials. Okay, particular solid materials. Shear or addition forces reach the end product of particular materials is micrometer range. Okay, in the case of ultra grain size reduction machine, the final end product will be submicron range. That will be easy to handle. Okay, based on cutting forces, it gives our preferred size and shape of the products. Okay, these are all the basic principles and the mechanisms of size reduction in food. Okay, or combination process in foods. Okay. Next we can move into the continuous of mechanisms in size reductions. In the case of grinding process, materials are reduced in size by fracturing them. The grinding process, in the case of grinding process, the materials will size will be reduced due to the fracturing process or fracturing them. Okay, for example, you have to giving stress to the particular unit, it will be breakdown into the several it leads to strains in the solid materials. The strains leads to fracture in lines of weakness. The fracture in lines weak is leads into breakdown of solid materials in different sizes and also releasing the heat. Okay, heat energy. Okay, first, energy for size reductions. Energy requires depends upon the hardness of the material, the tendency of the material to crack. Energy requirement for size reduction is will be depend on hardness of the material and tendency of the material to crack. Okay, the minimum energy needed to rupture the material, excess energy will be lost as a heat. These loss should be kept as the low practicable. Okay, the figures are less than 2% efficiency have been quoted. Okay, grinding is the very inefficient process, perhaps the most inefficient of traditional unit operations. Okay, much of the input energy lost in deforming the particles within their elastic limits through interparticle frictions. Okay, a large amount of wasted energy is released as heat, which in turn may be responsible for heat damage or biological materials. Okay, grinding is the very inefficient process and is important to energy as efficiently as possible. Okay. The energy required to reduce the size of solid particle is calculated using one of three equations. The main three laws are applicable to size reduction practices. First one Kick's laws, second one Rittinger's laws, third one Born laws. Okay. In the case of Kick's laws is denotes that the energy is required for a given size reduction was proportional to the size reduction ratio. Okay, size reduction ratio. This is the statement of Kick law. In the case of Rittinger laws, for the grinding of solids, the energy required should be proportional to the new surface producer. This is the statement of Rittinger laws. A Born law is the Born law principles is the communication law is the Born law is defined as the reduction or inversely the reduction was inversely proportional to the square root of size is new size is produced. This is the statement of Born law. Okay, this is example some for applying Rittinger's laws to the size reduction process. Okay. Next we have moved into the equipment using for size reduction process. Okay, the principal types of size reductions machines are follows. First one, a crushers. In the case of crushers, three types of crushers are there: jaw crusher, grate crusher, and then crushing rolls. Second one, grinders, hammer mills and impactors, rolling compression mills, and then addition mills. Third one, ultra fine grinders, hammer mills with the internal classifications, fluid energy mills, agitator mills, and bar mills. Cutting machines, knife cutters, dicers, and slicers. These are all the size reduction equipments using for size reduction process. Okay. First, we are going to see about crushers. In the crushers means we are using compressing force to crushing the particular product. Okay, jaw grating crushes are raw material down into the progressively narrow air spacing resulting in size reduction. That means the big solid materials for falling materials pass through in the small space in between the two moving jaws. The jaws is responsible to reducing the size of big particles. Okay, this is the jaw crusher. This is the grate regressors. In the case of jaw crusher, the solid passes through narrow space and break down into the small particles. In the case of grate regressors, in the particles are passed through the narrower place. The blade will be rotating due to the rotating force. The solid will be reduction into small size of particles. Okay. Next, move into the hammer mills. In the case of hammer mill, which contains a high-speed rotor turning inside the cylindrical case, the rotor carries the collar bearing number or hammers around the periphery. Okay, by rotating action, the hammer swing through the circular path inside in the casing containing the toughened breaker plate. Okay, feed passes into the action zone within the hammer, driving to the material against the breaker plate and forcing it to pass through the bottom mounted screen by gravity when the particles attain the proper size. In the case of hammer mills, feeds are fed into the feed tube. The rotating hammers will be there in the central part of the hammer mills. Okay, the rotating hits will be break down the large solid particles into the small size particles. Okay, and the hammer is the responsible hammer-like structure is the responsible for the breakdown of solid particles from bigger size to smaller size in the hammer mills process. Okay, hammer mills is mainly used for reduction in reduction of size particle due to impact forces. Okay, in the case of presses in the case of presses using compression force. In the case of hammers using impact forces. Okay, the hammers may be replaced by the knives or other devices give the build the possibility of handling tough ductile and fibrous materials. Okay, in the food industries, extended use of grinding spices, sugars, agrolimate, dry fruits, and dry vegetables. Okay, this picture shows the process of hammer mills. Let's move into the addition mills. Addition mills are also known as the plate mills or dice pulverizers and are the widely used in the small scale milling. That's widely used in small scale industries. These mills are used for working principle of shearing and then cutting forces, and the material feed between the two circular plates, which is the fluid or roughened surface fluid or roughened surface. One of the plates is fixed while the other has be rotation facilities. Okay. Normally, the material feed into near axis of the rotation and then sheared and then crushed. Okay. In the case of addition mills, the input will be passed through the feed inputs and the feed inputs and the feeds are following through and pass through the different plates. The first plate will be fixed plate, second plate will be rotating plate. In the case of passing through these plates, the particles will be particles will be divided into several parts due to then the rotating blades. Okay. This is the process of addition mills. Okay. This kind of mills produce the narrow range of particle sizes. The low clearance and higher speed facilities the production of finer size particles in the plate mills, leading to the development of the colloid mills. The main difference between them, clearance between the plates and then speed of rotations. These mills are extremely used in sear, curl, granulate, grind, shear, twist, bend, and rub kind of processes. Okay. This is the grinding mill working principle. First one is fixed plates, second one is rotating blades. The grinding materials pass through the fixed plates and break down into in between the gaps of rotating blades and then fixed blade. Okay, this is the additional working principle. Okay. Next one, tumbling mill or ball mill. Tumbling mill is to many industries for fine grinding. It is basically consists of horizontal, slow speed rotating cylinder that is but partially filled with either balls or rods. Okay, the cylindrical cells is usually made of steels lined with the carbon steel plate, porcelain slice. Silica rock and then rubbers. Okay, the ball are normally made out of steel or flintstones, while the rods are used for manufacturing with high carbon steels. Okay. In the case of tumbling or ball mills, the structure will be halfly filled with in the ball-like structures. The ball manufactured from the materials of carbon steels. Sorry, manufacturing of from steels, flintstones. Okay, in the round-like structures, the bars will be responsible for breakdown of solid materials. In the case of tumbling mills, the feed will be passing through the feed inlet, and then in the stretch and the whole structure will be rotating along with the stones. The stone will be the stone will be collided with the solid particles. Due to colloidal process, the size of solid particles will be reduced. The reduced size of particles will be collected through the outlet medium. Okay, outlet medium just using impact forces. Impact forces means the balls are collided with particular solid particles, or impact with particular solid particles. The solid will be reduced due to the impact forces in the case of tumbling or ball mills. Ball like structure is responsible for size reduction process in the case of tumbling mills or ball mills. Okay. Okay. The picture shows exactly the processing of ball or tumbling mills. Feed will be entered into the feed inlet, and the feed will be passed through the rotating cylinders. And the cylinders has different types of balls like structures. And the ball like structure is responsible to break down the solid materials. After the breakdown of solid materials, the small size particles or small size solid particles collected through the outlet. Okay. The picture shows red color, the red color is the red color denotes balls. The green and yellow color, it denotes different size of particles, denotes different types of particles. This structure will be rotating continuously. Due to rotating process, the balls are the red balls are impact with the solid materials. The solid materials divided into different sizes of solid particles. Okay, this is the main process of ball mill or ball mills. Okay, or tumbling mills. Okay. Next one, cutting machines. Cutting machines is responsible for slicing and flaking of food materials, dicing of food materials, shredding of food materials, pulping of food materials. Okay. In the case of slicing and dicing, blade slices by centrifugal forces. In the case of shredding, commonly they are modified form of hammer mills. Pulping is combination of compression and shearing forces. This is first one is the picture shows shredding, cutting, and then slicing, and then dicing method of size reductions. Okay. Next one, homogenization. The unit operation that prevents the fat globules from the coalescing into the cream is called as homogenization. Homogenization means which also way of size reduction in liquids. The liquid formulation is forced through small opening at the higher speeds. Breakdown of fat or other globules into the smaller ones is the responsible of homogenizations. Okay, high speed mixers, edges and tips of blades, high-speed turbines or propeller types of mixers impact or shearing action on the low viscous food formulations to homogenize into the smooth homogeneous emulsions. Okay, this kind let's move into the pressure homogenesis. Pressure homogenization is conveniently done prior pasteurization and ultra fine temperature sterilization. Okay. Ultrasonic homogenesis. This type of homogenesis is used to for the production of salad creams, ice creams, synthetic creams, baby foods, and then essential oil emulsions. Okay, these are all the basic introduction about size reduction and then size reduction equipments. Uh, uh, I have hope you are gain basic knowledge about size reduction equipments used in food industries. Thank you for opportunity. Thank you once again. Thank you so much. Okay.